Derivatives of logarithmic functions. The definition. The derivative of natural log of x, which natural log can also be written as the log base e of x. But because this is such a special case, we can simply write it as natural log of x, ln of x. So if you've seen the other video I produced, you know about the derivative of the number e, and natural log is the inverse of e. So if you see the other video first, this concept will be much clearer. So here we're going to clarify the definition. So y is equal to natural log of x. Raising both sides as exponents with base e, we find that e to the y is equal to x, because e to the natural log cancel because they're inverses. So e to the y is equal to x. Now let's derive. So d dx e to the y equals d dx of x. So e to the y times dy dx is equal to 1. So dy dx is equal to 1 over e to the y. E to the y is x. So dy dx is 1 over x, where this x here is a differentiable function because it needs to be able to be derived here, and also where x does not equal 0, because 1 over 0 is undefined, and that's no good. So the rule, therefore, is simplified as derivative of natural log of u is equal to 1 over u times the derivative of u. Another logarithmic function is in the form of log base a of x. So the change of base formula can be used when dealing with these types of derivatives when the a is greater than 0 and does not equal 1. So the log base a of x is equal to natural log of x divided by natural log of a. So d dx of log base a of x is equal to d dx natural log of x divided by natural log of a. This results in 1 over natural log of a times d dx of natural log of x, which is equal to 1 over natural log of a times 1 over x, producing 1 over x natural log of a. Thus, the derivative of log base a of u is equal to 1 over u times natural log of a times derivative of u with respect to x. And this information is important to realize when things are undefined, or simply just to take note of in your answer. So what our derivative means is that the derivative of log base a of u is equal to 1 over the main argument times the natural log of the base of the logarithm times the derivative of the argument, u. So 1 over this times the derivative of u. An interesting way to remember this is knowing that derivative of log base a of u is 1 over ulna, just remembering the simple phrase ulna, because u, natural log of a, can be pronounced as ulna, times just du dx. So 1 over ulna du dx. So differentiate y is equal to natural log of the quantity x squared plus 1. So y prime is equal to 1 over the argument x squared plus 1 times the derivative of the argument, which is 2x. So y prime is equal to 2x divided by x squared plus 1. Relatively simple example. Derive y is equal to the natural log of 10 divided by x. So y prime is equal to 1 over the quantity 10 divided by x times d dx of 10 divided by x. So y prime is equal to x over 10 times negative 10 divided by x squared. This can be multiplied out as negative 10x divided by 10x squared. Some simplification can occur, giving us the result of negative 1 over x. Also can be written as negative x to the negative 1, but this can become complex with multiple negative signs, and this is an equally useful form. Differentiate y is equal to natural log of 2 times log base 2 of x. So y prime is equal to natural log of 2 times 1 over, if we say 2 is a and x is u, so 1 over ulna, x natural log of a, so 2. Y prime is equal to natural log of 2 divided by x natural log of 2. Cancellations occur. Y prime is equal to 1 over x. And it's important to note that x is greater than 0, or else we have an undefined answer. And so this initially looks rather complex because we have natural logs and logs with unfamiliar bases. But what you have to remember is that the natural log of 2 is simply a constant in a more complex and non-numerical form. So natural log of 2, if you plug that in a calculator, will just give you a number. So we know that when we're dealing with constants in differentiation, we just multiply them through. So for example, y is equal to 2x squared. Y prime is equal to 2, we're just leaving the constant alone, times 2x, the derivative of x squared. Ultimately, this constant gets multiplied out, but the constant is left alone. So the natural log is simply left alone until it's canceled because of like terms, and we're left with 1 over x as our final result.